Hello, my name is Myung Kim, and this is a brief review for our nanoelectronics class. And today I'll be talking about the concept of energy bands. The energy bands, before we get in, I have to talk about one specific atomic model, being a Bohr model. You can see the picture of hydrogen atom, and what the Bohr model tells us about this hydrogen atom is each electron, there's a one specific orbit for each hydrogen atom. Now, when the multiple atoms meet, because of a certain principle called the Pauli exclusion principle, Pauli exclusion principle being no two more electrons can occupy the same state, new energy states, new atomic orbitals are born. They split into a multiple new molecular orbits, and those excess electrons will occupy those newly formed orbits, and the orbits now we call the energy bands. Right. I just told you about how the energy bands are formed, but one question you'll be having is like, why does this matter? Why do we need to know about these energy bands? Well, we have to know about energy band because I will show you the picture right here. Because of these two specific energy bands, being the valence band, the green one, and the conduction band, the yellow one. Each definition is at temperature of 0 Kelvin. The valence band is full of electrons, while the conduction band is the lowest level of energy band that has 0 electrons. When the temperature goes up to 1 Kelvin or upper many kelvins, electrons in the valence band jumps up to conduction band, and when that occurs, the electricity conducts. Hence why it's called conduction band. And I don't have to explain why the electricity is important. It's just important. So the next thing I'm going to talk about is the EK diagram. The EK diagram is what it shows us is that the materials, it shows a energy band of material under a different momentum of electrons. Now, why is this important? Well, it's important because it can distinguish certain types of materials being direct and indirect band gap materials. And I have the picture right here. Now, why these two are important? Well, because, as I told earlier, electricity conducts when the electron moves to valence to conduction band. So, as you can see from the picture above here, direct band gap has a direct conduction and valence pathways, while the indirect band gap has a longer and more complicated pathways. So when conducting electricity, the direct band gap is more easily conductible because it has short paths to travel. Well, that's about it about the lessons of energy bands. Well, thank you for listening. This is Myung Kim of the semiconductor class.